What if your team is sitting on thousands of pages of technical documentation, standards, manuals, configuration files, and engineers are wasting hours just searching for one attribute? And what if you cannot send any of that data to the cloud because it has to stay fully offline and air-gapped? We built a system that solves exactly this, and we want to show you how. We are DaemLabs, an AI agent automation agency. We build RAG systems, voice agents, and automation pipelines from scratch for real engineering and business problems. This is one of our projects, a fully offline document intelligence system built for a substation automation use case. But the architecture is generic enough for any technical domain.
Here is the problem we were solving. Electrical engineers were manually searching through massive IEC 61850 standard documents. Hundreds of pages, nested tables, logical node definitions, data attributes. Normal Control-F search does not understand meaning. And standard RAG systems break down too. Compound questions get mixed into one vector, and the important details get drowned out. On top of that, everything had to run completely offline. No internet, no cloud APIs, full data privacy. So we built a complete offline document intelligence pipeline. Local LLMs running through Ollama, a local vector database called Qdrant, a SQLite cache layer, a cross-encoder re-ranker, and a React frontend talking to a fast API backend over streaming connections. Every piece of this runs on a single machine, no external calls. Let me walk you through how it actually works. First, ingestion. We built a generic layout classifier that reads any technical PDF and splits it into two types of content, prose blocks and table blocks. Tables are the tricky part. A full table is too large for accurate search, but a single row loses all its context. No headers, no category, nothing. So we built a parent-child structure. Each table becomes a parent chunk with the headers and metadata. Every row becomes a child chunk linked back to that parent. When we retrieve a row, we automatically pull the parent headers back in, so the LLM always sees the full context. Now speed. This is where it gets interesting. We built a double caching engine. The first layer is an exact match cache using SQLite and SHA-256 hashing. If the exact same question comes in again, the answer comes back in under 1 millisecond. The second layer is a semantic cache in Qdrant. If a question is asked differently but means the same thing, cosine similarity above 0.99, we return the answer in around 10 milliseconds. No LLM call at all. And we made sure negative responses like "I could not find this" never get cached. So a temporary failure never pollutes the system. Next, conversation memory. If a user asks, "What is SIMG?" and then follows up with "What are its pressure attributes?" a normal vector search on that follow-up completely fails. The word "its" means nothing on its own. We solved this with a two-phase approach. A fast regex check detects pronouns instantly with zero overhead. If pronouns are found, we send the last few turns to a small, fast model, Qwen 2.5 3 billion parameters, capped at 24 tokens output. It rewrites the question into a standalone query in under 150 milliseconds. This keeps the conversation natural without bloating the prompt with massive history tables. Compound questions are another problem we solved. If someone asks one question that actually contains 2 or 3 separate technical concepts, a single vector search drowns the smaller details under the bigger one. So we built a multi-intent splitter. It detects compound questions, splits them into separate subqueries, runs parallel searches and re-ranking for each one, then merges everything back together. So every part of the question gets a proper answer. Now streaming. Local LLM streaming over a connection is not always reliable. Tokens can get cut off, network hiccups, GPU memory pressure, packet issues. We built a self-healing validation layer. The backend sends the full answer along with the stream. The frontend compares what it received with that full answer. If anything is missing or cut off, it silently triggers a fallback request. And because the answer is already cached, it comes back in under 10 milliseconds. The user never even notices. A few more things we built into this system. Hierarchical reference passing,
So something like a deep object path gets automatically broken down and explained step by step. Dynamic healing. If any data is missing from the database, the system reads the original PDF page in real time and repairs it instantly, then caches that fix forever. And one-click Excel export. The system takes any answer, restructures it through the LLM into clean JSON, and generates a fully styled, formatted Excel report.
Let's talk numbers, because this is what actually matters to a client. Exact cache hits under 1 millisecond. Semantic cache hits around 10 milliseconds. Conversational query rewriting under 150 milliseconds. We also reduced a 26-second startup bottleneck down to under 1 millisecond using persistent caching. And on a full test suite of 20 technical questions, 100% correct, complete and verified answers. Zero hallucinations. All of this running on a consumer laptop with a 6GB GPU. So why does this matter for you? Because we have already solved the hard problems. Offline LLM deployment, caching architecture, conversational memory, self-healing pipelines, and document parsing that works on any technical PDF, not just one format. Whether your use case is engineering documentation, compliance manuals, internal knowledge bases, or anything that needs to stay private and offline, we have the architecture and the experience to build it for you.
If you have a document intelligence or RAG problem, especially one that needs to run privately, offline, or on-premise, come talk to us. Visit DaemLabs.com or reach out directly. We will understand your data, your constraints, and build a system that actually works. That is what we do.